Alright guys, so what you're going to do is you're going to try this gizmo called Sticky Molecules. It's all about intermolecular forces, and it kind of simulates some of those intermolecular forces. So it should be there on your dashboard. Click on it there, and for you it'll come up like this. And then just click on the link that says take you to explorelearning.com. You're going to have to log in, and then as soon as you get logged in, it will take you to a page, and you can click on the thing there that says Sticky Molecules. Remember, your login is probably the first part of your email address and then your ID with or without the zeros. So if it's smith4567@students.d211.org, your username is probably smith4567, and then your password is probably your ID. Try it with the zeros, try it without the zeros. If you still can't get logged in, either work with a partner, because it's not critical that this is done by yourself, or talk to the teacher, and the teacher probably has access to your login code. So you're going to do the one that says Sticky Molecules there, and so you're going to hit launch. And what you're going to do is you are going to look at 4 different substances, and you are going to examine their polarity, their drop diameter, their tilt angle, their surface tension, and their capillary rise that is there. So first thing we're going to do is we're going to start with polarity. So I'm going to drag the polarity tool up from the bottom and stick it there where it says the tool. And then I'm going to go ahead and I'm going to pick a substance, like I'm going to pick water here. And then it says use the dropper to add liquid to the petri dish. So I do that, and now it's going to give me a microscopic view of what is going on. Now you'll notice that as these guys bump into each other, we've got these little dotted lines showing up. You should know what those dotted lines are. Those are intermolecular forces. So that is telling you that water is indeed polar. So I'm going to come over here and I'm going to click P for polar for the water. Now I'm going to try the hexane. And I'm going to come over here, I'm going to add a little drops of hexane there, and it's going to give me a picture again. Look at those big molecules moving around, but as they bump into each other, you'll notice that there's no lines that are between them. And if there's no lines, that is telling you that there's no real strong intermolecular attraction between those substances. So this substance is clearly a non-polar molecule. So the hexane there would be non-polar there. Then you're going to finish for glycerin, and you're going to finish for mineral oil. Then once you do that, you're going to do the remaining 4 experiments, and you're going to collect some data. So you're going to do, for example, drop diameter. So clear all that, reset, and I'm going to put drop diameter up here. And then I can put anything I want. I can start with water again. So I'm going to put drop diameter for water, and I'm going to click it there. And then you'll notice that they gave me a little ruler, and then the little ruler, I can go down here and I can figure out how many millimeters that thing is. It looks like the drop diameter of water is about 6 millimeters. So I'm going to go ahead here and put 6 millimeters in for my drop diameter. Then I'll reload with hexane there, and I'll put that in, and you'll notice that hexane is a much larger drop diameter. Why does that make sense based upon what we know now about their intermolecular forces? So it looks to me like hexane has about a 20 millimeter drop diameter. You can go ahead and put that in like so. And then you can do the same thing for tilt angle, surface tension, and capillary rise. So you can put the tilt angle in, and if I were to, again, start with water, I'm going to put a drop of water on, and then what I'm going to do is I'm going to start this, and I'm going to raise it, and at some point, the drop is going to begin to slide down. At some point it's going to break its intermolecular forces, and it's going to begin to slide. So water, it looks like I'm getting all the way up here to 18. So 18 degrees it took for water before that dot slid down. Repeat for the other ones that are there. Surface tension. If I were to do the surface tension one, what you do is you put the water in, and then you put that down, and then you crank the handle down a little bit, pull down on the bar, come on, pull down, there it goes. So you pull down on the bar, and you'll notice at some point, there it goes, at some point the water will drop off of that. So You notice I'm drawing the water up, I'm drawing the water up, I'm drawing the water up, and eventually I'm going to get to a certain number and the water is going to drop off. Record the amount that it took for it to drop off. And then our last one here is the capillary, kind of like what we did in class. You're going to put that in, and then the liquid is going to go up the tube, and then you are going to measure how far up the tube it goes with this. So you've got 5 different experiments with 4 different substances here, and you should be able to fill out this whole data table here, and then you should be able to go back to Schoology and then answer the questions that are here for these guys. You're going to put down whether or not they're polar or non-polar. You're then going to put them in order of smallest to largest diameter, and so forth and so on, and answer all of these questions that are here for your Schoology assignment. So give it a try, give it a go. I think once you get the hang of it, it's actually a little bit fun, and it'll show the differences between polar molecules and non-polar molecules as far as a bunch of their different properties are concerned.